Section 4.1, solving systems of equations. So going to the movies by yourself is very easy to calculate how much you will be spending. But what if you were taking others and you had to pay for all? Never fear, there are many applications out there that can help you calculate totals. This section will demonstrate different ways on how those fancy apps might be using to come up with solutions. The first way will be graphically, the second way will be the method of substitution, and the third way will be the addition method. So first, let's take a look at linear and nonlinear systems of equations. All equations in the form ax plus by equals c are straight lines when graphed. Two such equations are called a system of equations or a linear system. So we call this a system of equations. A solution to a system of linear equations in two variables is an ordered pair that satisfies both equations in the system. A system of linear equations can have exactly one solution, no solution, or infinite many solutions. A linear system that has at least one solution is called a consistent system. So consistent. And a linear system with no solution is called an inconsistent. For example 1, we have determine if the given points are solutions to the following system. Our system is 3x minus y equals 0 and 2x plus y equals 5. So we're going to go ahead and plug in these 2 points in my equations. Remember, this is x and this is y. So let's try the first one. So we have 3 times 2 minus negative 3 equals 0. Okay, so 3 times 2 is 6. Negative times a negative is a plus. 3 equals 0. 6 plus 3 is 9. Is 9 equal to 0? No. So we don't need to go further. That means that this is not a solution. So not a solution. Let's take a look at example B. We have 0, 0. So let's see, 3 times 0 minus 0 equals 0. 3 times 0, 0 minus 0 equals 0. 0 equals 0. Yes. So far it looks like this is a solution. So we need to go ahead and plug it in on our second equation. So we have 2 times 0 plus 0 equals 5. 2 times 0 is 0 plus 0 equals 5. Is 0 equal to 5? No. So that means that this is not a solution. So let's go ahead and take a look at example C. 1, 3. So we're going to plug in those numbers. So 3 times 1 minus 3 equal to 0. 3 times 1, 3 minus 3 equal to 0. 3 minus 3, 0 equal to 0. Yes. So again, so far it looks like it's a solution. We need to check our second equation. So we have 2 times 1 plus 3 equals 5. So we have 2 times 1, 2, plus 3 equals to 5. 2 plus 3, 5. 5 equals to 5? Yes. So that means that this point is a solution. Example 2. Again, determine if the given points are solutions to the following system. So we have our system. And we're going to go ahead and check this point. Again, this is x and this is y. So let's plug them in. So we have 2 times 1 minus 3 times 2 equals negative 4. 2 times 1 is 2 minus 3 times 2 is 6 equals negative 4. 2 minus 6, negative 4 equals to negative 4. Yes. Okay, we need to check the second equation. So we have 2 times 1 plus 2 equals 4. 2 times 1, 2 plus 2 equals 4. 2 plus 2 is 4. 4 equals 4. Yes. So that means that this point is a solution. All right. Example B. This one you can go ahead and try it out on your own. So for example B, try it out. All right, so a system can be a system with only linear equations or a system with nonlinear equations. There are three ways to find the solutions to a system. The three ways are substitution, elimination, addition, and graphing. The solution to a system is an intersection of the graphs. Let's take a look at the graphical method. To find the solution graphically, we graph each equation on the same Cartesian plane and find the point of intersection. The intersection is the solution to the system. We need to check the solution like we did on the examples before. A linear system can have one solution, no solution, or infinitely many solutions. Now, for example 3, find the solutions to each system below if it exists. So wherever they cross, that's going to be my solution. These two lines are crossing right here. So what point is that? That's 1, 2, 3 for my x. So that's going to be 3, comma, 1, 2, 3, comma 3. Let's go ahead and check that solution. So for this one, we have 3 plus 3 equals 6. 6 equals 6, yes. Now let's check this one. So we have 2 times 3 minus 3 equals 3. 2 times 3 is 6 minus 3 equals 3. 3 equals 3, yes. So my solution is good to go. Let's take a look at example B. Again, wherever my lines intersect, that's going to be the solution. So these lines are crossing right here. Let's see what point is that. So we have 1, 2, 3 for my x. So we have 3, comma, and we have 1, 2, 3, 4 for my y. So the point is 3, comma 4. Let's go ahead and check that. So we have y equals 3x minus 5. So we have 4 equals 3 times 3 minus 5. 4 equals 3 times 3 is 9 minus 5 is 4. So 4 equals 4, yes. Now we have 2 times 4 plus 3 equals 11. 2 times 4 is 8 plus 3 equals 11. 8 plus 3, 11. 11 equals 11. Yes. So that means my solution is correct. Now for example 4, find the solution or solutions to each system below if it exists. Let's take a look at example A. If you notice, my lines never intersect. So that means that this system has no solution because our lines never cross. So this is going to be no solution. Now for example B, we have y equals 3x minus 1 and 2y equals 6x minus 2. If you notice, we only have one line. What that means is that it's a line on top of the other line. Let's take a look at that. So if you notice, I have y equals 3x minus 1 is my red line. Let's see what happens when I graph the second line. 2y equals 6x minus 2. It's a blue line now, but it's exactly the same one. That means that these two lines are intersecting each other at exactly all the points. That means that they have infinite many solutions. So for example B, my answer is going to be infinite many solutions.